What is T1? T1 is an analysis suite for creating better embedded software. T1 lets you look inside your software to make the best of the available resources and build safe and reliable embedded systems. T1 is actually a product family, and let's now take a look at T1.timing. Here you see the user interface of T1.timing. On the left side in the target control, you see that currently the T1 target software is tracing. So the T1 target software is the component that runs on the ECU as part of the ECU software, and the ECU is currently lying here on my desk connected through the CAN bus. I can now download a trace, and a few seconds later we see the downloaded trace with all its tasks and interrupts as they executed. You can see that in the center view here. We have a timeline. We have on the other axis all the tasks and interrupts. And now the colors indicate the task states over the time. That's also true for the interrupts. So a bright color indicates ready state, dark color running state. So with really a quick glance at this picture, you see what is going on in your software. You identify hotspots easily. You identify all kinds of timing problems, really. All kinds of timing problems on the scheduling level. So this is really the right flight level for analyzing timing problems on the scheduling level. In addition to this view, you get all the numbers in the timing information view, where again you see all the tasks and interrupts here, and for each we have the timing parameters such as core execution time, delta time, cross execution time, response times, jitter, and so forth, even with distribution curves here at the bottom. And here you see the min, max, and average values. They come with hyperlinks so that you can jump directly to the corresponding position in the trace. T1 uses software instrumentation to collect the relevant data. This comes with many advantages. What you just saw works on your desk, in the lab, at the hill, in the real environment of your embedded system, well, actually in the final product itself. There's no need for any special hardware or dedicated trace interfaces. You also don't need to stop execution of your software. You don't even have to watch the results yourself all the time. T1 can do that for you. What you see here is the T1.cont table view. It shows you selected timing parameters such as maximum core execution time or maximum minimum response times. These values get calculated by the T1 target software as part of the embedded software running on the ECU. The results can be stored in non-volatile memory, and that gives you a very broad basis for your timing profiling. T1.cont doesn't stop at measuring the values. We can also supervise them, as indicated here by this little red flag. It indicates the maximum allowed core execution time of this task here. We call it a timing constraint, which allows you to implement a supervision for your timing requirements. Obviously, the whole setup works even if no PC or laptop is connected to your embedded system. So, T1 can analyze the timing as part of the embedded system, and it can be used on the road. You might wonder how we deal with safety requirements. Well, take a look at this. This is an ISO 26262 ASIL-D certificate for the T1 target software. Since our first certification back in 2016, T1 has become part of many mass production ECUs, and among these are braking or steering systems, so really the safety relevant projects. Show me any other timing tool that comes with an ISO 26262 certificate. Let me round off this T1 timing overview by doing some magic. T1 Flex is the magic component which allows us to instrument the software while it is executing. And when I say executing, I mean executing from flash. First of all, I'll start by instrumenting some runnables. I can do that simply by clicking on the task for which I want to instrument its runnables. Just select the option, and now in the background these runnables get instrumented. So when I now download a new trace, I will see the runnables. They are visualized as ovals inside the task, as you can see here. Alternatively, I click this little plus here and I see the boxes, one for each runnable. Do we stop on the level of runnables? No, we don't. T1 allows you to read in the L file so that you have a view on all the symbols. So here you see all the functions. And since this is a really production version of the software, there are thousands of these functions. I can now select any function I'm interested in, right click on that function, and immediately this function gets instrumented. In the background again, I can now switch to the T1 table, scroll to the bottom, and here you see the timing parameters, the most important timing parameters of the function that has been instrumented on the fly. Core execution time, max, min, average, delta time average, and the average CPU load. We don't even stop on the level of functions, because if you do have the source code available of that function, you can simply open it, select any fraction inside your function, right-click on your selection and start a measurement on just those lines inside the function. Again, the T1 table view shows you now for this fraction of the function the timing parameters min, max, average, core execution times, delta time, and the CPU load. Again, all of this is possible without having to modify the source code, recompile it, link, flash, and so forth. You do that on the fly, and timing analysis becomes very, very easy and very, very fast. Summary. T1 has been on the market since 2003 and has helped thousands of mass production projects to get their resources under control. In this episode, I gave a brief introduction to T1 timing. The other members of the T1 family are T1 stack, T1 access predictor, T1 POSIX, and T1 streaming. There are separate episodes for those, and there are also more detailed videos on the plugins I mentioned in this video. Check them out, and thank you for watching.